Alright, so now that we know what an inequality represents, how do we solve them? And here's some really good news for you. This section almost serves as a great review of sections 2.1 and 2.2 at the beginning of this chapter, because we're essentially going to use the same game plan, if you would, that we did with equations, right? So the same exact game plan. That game plan was to simplify both sides, right? So we did some simplification, and then we did some addition and subtraction to both sides, and then we did some multiplication and division both sides with our golden rule. So it turns out that we can use the same process, the same game plan, to solve our inequalities. So let's see that in action. So to solve this less than statement, I have to start getting this x by itself. So I would begin, just like I would do if it was an equation, I would subtract 3 from both sides. And yes, please make sure you're showing me that work, right? It's a skill we're learning, so it's a skill I want to see. So physically show me that you're subtracting both sides by 3. And then now what I'll do to get this x by itself is I would divide both sides by 2, right? The 2's will divide out, giving us x, and then 4 divided by 2 is 2. And so there's your solution. X is less than 2, all right? So there's the solution. In another video, we'll actually take a closer look at what this solution means and how to check it and all that. But right now, I just want to focus on how we solve it, and basically hope with that one example you see that it's essentially the same thing as equations. So in the next one, we have a challenge here because we have x terms on both sides and non-x terms on both sides. So we're going to simplify first, well, nothing to simplify, and then next we're going to add and subtract. So perhaps we subtract x from both sides, and when we do that, we can add 1 to both sides. So my inequality will now look like over here we end up with a 2x, and over here we end up with a 6. So to continue to solve, to get x by itself, I would divide both sides by 2. Again, the 2's divide out, and we're left with the solution, x is less than or equal to 3. All right, and then again, what that solution means, we'll talk about that later, but for sure we got x by itself, and we found the solution to that inequality. All right, so same game plan. Here, if we solve this greater than, we have some simplification we need to do first. So distributing, I get 2x plus 4 minus 1. Here, be careful, we're distributing a minus, so that changes all the signs behind. Simplifying still, we're going to combine like terms. So on that left-hand side, we get 2x plus 3. And on the other side, it looks like we get a negative x plus 2. All right, so not real pretty, but that's what we get. Now we're going to add and subtract the same thing from both sides to collect like terms. So perhaps I'll add x to both sides, and while I do that, I'll subtract 3 from both sides. And so that the 3's will cancel out. 2x and x gives us 3x. And then over here, 2 divided by 2 take away 3 gives us a negative 1. All right, and so to wrap this one up, I would basically divide both sides by 3. The 3's divide out, and so the x's we're looking for are greater than negative 1/3. All right, and yes, it's okay to have fractions as part of our answer. Right, they're numbers too. All right, so again, what that means, we'll address in another video, but there's the solution. X is to the right of or greater than negative 1/3. All right, and so what about fractions, right? Those ugly fractions. Well, remember earlier in 2.2, part of our game plan, when we simplified, right, when we did a simplification, we cleared the fractions. We took advantage of the fact that I can do whatever I want to both sides and cleared the fractions. We did that by finding an LCD. So looking at my denominators here, 6 serves as an LCD. So my first move, before I do anything else, part of that simplification process, is to take both sides of the equation and multiply by 6. I'll write it as 6 over 1 so we can do our fraction stuff. So on this side, right, this is pretty easy. This is 6 over 6, which is 1, right? 6 over 2 gives us 3x, plus when I multiply 6 over 1 and 1/3, we get 6 over 3, which would leave us with 2, right? So I'm distributing over here. 6 over 2 is 3, 6 over 3 is 2. So now my fractions are cleared. So we're back to playing our game of adding and subtracting. So perhaps I'll subtract 2 from both sides. right? And that'll give us 3x is greater than or equal to -1. Divide both sides by 3, and we get, in this case, x is greater than or equal to -1/3. Just a coincidence that ended up being the same answer, right? That doesn't usually happen. All right, so there you go. Last but not least, what happens if we run into an equation with decimals in it? Well, remember, decimals are just fractions. So we'll use the same simplification trick. Why don't we clear the decimals? So looking at this, this is tenths, and this is hundredths, right? There's a tenth, and this is hundredths. So my LCD here is 100. So I'll begin this journey by multiplying both sides by 100. Right? And by multiplying, we distribute. And it's effectively, since we're multiplying by 100, it moves the decimal over twice. So we get 20x. Moving the decimal over twice, that's 35. Moving the decimal over twice, when I distribute here, this is a 10x. And then plus 45. So we're no longer looking at those crazy decimals. So we've simplified. All right, so now we add and subtract. So looking at this, perhaps I subtract 10x from both sides. And as we do that, we can be adding 35 to both sides. All right, so over here that divides, or excuse me, cancels out. 20x take away 10x is 10x. And then those cancel out. 45 plus 35, I believe, is 80. Right? Finishing this off, we perform a division. I'll divide both sides by 10, and we basically get x is less than 8. All right, so there's your introduction or your method of solving inequalities. The good news is it's very similar to solving equations. You basically play the same game plan of simplifying both sides as much as possible. When you're done with that, you play the golden rule of adding and subtracting to get like terms to the same side. And then you usually finish off with some sort of division or multiplication to get the variable by itself. All right, and so we've got some more work to do. There's some nuances that we'll talk about, as well as we need to figure out exactly what these solutions mean and what they look like. And those will come down in some videos in a moment. All right, see you guys in the next part of the module.